Let us start. Hello, everybody. I'm so happy to be here. Privyet? Is that how you say it? Hi, I'm glad to be here. We're going to talk about serialization protocols in distributed systems. And I left out the Scala part because it scares people. But there's going to be some code, and there's going to be some concepts, and let's talk about them. But, well, first, my name's Chris. That's my Twitter if you want to complain about it, about the talk. I'm from Munich. I came here for that. I work for Mathmatch, which is a material search engine, and it doesn't matter at all for this talk, so you can forget about it. And even though the name is Mathmatch, it's about materials. It's not a dating platform until you're like 80% titanium. Otherwise, don't bother. But why I'm giving this talk about serialization protocols is before I joined Mathmatch, I was a software consultant. And I built a lot of systems, a lot of distributed systems, and I made a lot of horrible mistakes. And occasionally I learn from my mistakes, and this talk is one about my learnings. And yeah, in one project we had to make a big discussion or a big evaluation of serialization protocols, or just, protocols that we could use for a certain project. And out of that I thought that might be useful for other people, that research we did. So and it spiraled out of control, and now I have a talk, and somehow I'm going around and hold it. But for an introduction, why would you care about serialization protocols? Yeah, it's yet another thing that's bothersome, and yet another thing that's annoying that you have to learn and that you need to wrap your head around. But I do think it's very important because system designs that we do, they are changing. I have been around for a bit. I have been around for, sorry, something's wrong? Sorry?
Could you please give me this type C for
the type C? This device?
Yeah.
Oh, of course. Of course. I'm happy to share. Okay, let's go on. So systems are changing. I used to build JEE nonsense, deployed it to Glassfish, and I built horrible big monoliths. Now I still build monoliths, but less horrible ones. But things are really changing, right? If you listen to or see what's going on, 5 years ago everybody was proclaiming microservices as the solution for everything. And now you see the conference talks about how they are not the solution to everything and what could go wrong with them. But that means people are doing it. Like if you see these catastrophe talks, you see that people are doing it. Microservice stuff is mainstream. It's happening everywhere now. Queues are starting to show up in mainstream architectures. And even in smaller projects, and at least with cloud native stuff, queues are becoming more and more common. Command query, response segregation, event sourcing is a pretty common design pattern nowadays. I do love it. I'm pretty happy about it. Occasionally, it makes a lot of sense to build it. And mostly, and I really hope this is true finally, we are not using databases as integration layers anymore. I really hope you don't, right? It's a terrible idea. But we've been doing that, right? A couple of years ago, we had one big Oracle database. We gave them boatloads of money, and we built 10 applications all talking to that one database table, and it was a mess. So that is gone. The way we build systems is changing, or has changed in the last 5 years, but not all the parts have caught up yet, I think. There's that quote from Tim Parrott that I love, where he said that distributed systems are about protocols, not implementations. Because there's all that talk about which languages should you write your microservices in, how big should they are, how many languages can you have? Like, can you have 2 backend languages? Do you have to write everything in JavaScript, even the backend? God, no. Do you have to write everything in Scala JS, even the front end? Oh, please don't. But I think the way these systems interact is way more important than how these systems are. If you are overly concerned with your services themselves, something went wrong probably. But the collaboration and the communication between services and all these bits and parts of pieces of your infrastructure, that's where the true interesting problem comes. There's also that nice quote from that book from Evolutionary Architecture from Rebecca Person and Neil Ford that says that or the whole book talks about that most of your application architecture should strive for evolvability. You want to change things as you go, because most things you know at the beginning they are wrong. Like everything you build in the beginning, at least for me, everything I build in the beginning, it's wrong. And over the time of the project, it gets less wrong. Sometimes it even gets a bit better, but you have to change a lot of things all the time. So your architecture should strive for replacing your mistakes instead of being perfect at the first step. And because I like to make quotes myself, I like to define that idea of evolvability as the ability of a system and its data to adapt to change. I couldn't find a better description. And that's the key part. The systems we're building, they're evolving and moving around, and they have to communicate. And that yields to problems, right? In the dark ages, monolithic systems, relational databases, if you had to do something, like you had to implement a new feature, you would do a schema migration. You would change your code. Then you would do one big deployment after 4 weeks of testing and QA, and would do a fairly big bang, and everything would blow up, and everything would be terrible. But that's how you did it. That's how we knew it. But if you have other systems, kind of like replicated systems, distributed systems, just your run-of-the-mill microservice thingy, you can't deploy the whole thing at once anymore. It doesn't make sense. And you probably want to stay up, right? We have distributed systems, maybe in our own data center, maybe in the cloud. Some crazy folks are starting to do serverless, so these things are not even on. They pop up and down all the time. And finally, there's also a lot of systems with code distributed to the user. For example, front-end thingies that keep running, right? People have their browsers open for a long time, and if you change something about the backend communication, suddenly all your active users are very angry at you. So I think the whole big bang deployment where you can change everything at once, it does not work anymore. You're stuck keeping the lights on, right? You can't just have a 4-hour maintenance window every week where you deploy. And that's why it gets interesting. One little sidekick is, we as software engineers, we love to make up new names, right? For serialization, I have found a lot names, or many names that we have to deal with. So you could talk about encoding data, you could talk about serialization data, and you could talk about marshalling data, depending on which ecosystem you come from, or vice versa. You could decode, deserialize it, or unmarshal it, and it all means the same. Or for the sake of the talk, it means the same, and I will go with serialization and deserialization because it's hard to pronounce and I need a challenge. So all these systems, they go up and down, they have to talk to each other. We need to deal with this. We need to exchange information between two parts, whatever they are. And they should understand what that means. So I'm looking a few slides here. But we just have to go without it, and we're done earlier, which is a nice thing to do. So if you have to exchange things between systems, you have a few usual suspects that's the first natural thing to do. And as always, the first natural thing to do, it's easy and it's wrong. But you do it anyway. So if you work on a JVM-based language, you probably know about serialization or java.serializable. So we have it, it's always there, it's in your JDK, and you can use it. You have to write it. There it goes. So please, for the love of everything that's holy to you, if you take one thing away from this talk, don't use Java serialization. Please don't. No, there's no excuse, never do it. It goes wrong so often. Just a couple of arguments for the people who are not yet convinced. I guess half of the talks are already. If you do it, you're bound to the JVM implementation language. You cannot even switch over to other JVM languages. You're bound to one language if you really want to do that. Performance-wise, let's not even talk about it. It's slow. It's really slow. But that's just the obvious but minor drawbacks. There are bigger drawbacks. If you listen to, not to me because I'm some random dude, but if you want to listen to Joshua Bloch, who wrote Effective Java, so he knows halfway what he's talking about, he even back then said to implement it judiciously, or to say very carefully, very sparingly, which is consultant speak for don't. Because yeah, if you use Java serialization and you release something, you're stuck. It has to be that way, right? Basically how it works, it takes the whole class that you're running or the whole instance and just writes it as a stream. And then when you want to read it back in, serialize it back in, you just have to hope the pieces fit together. And if they don't, you blow up and everything is in flames. And if you think about that a bit more carefully, that means if you serialize out your whole class, everything about your whole class suddenly becomes the API of your application. The most inner workings become the API. It's an obvious, not good thing to do. You want to keep that stuff separate and keep that stuff internally and expose a sane API to whoever you're interacting with. And because the JVM has to be pretty low-key about what it takes in to figure the pieces in, it just takes whatever you give it. And everybody concerned with security will say that's a very bad approach because you just read whatever somebody gives you and just pretends, take this byte stream, it will be an object, I promise you. There's no other things there, I promise. So if you do that, your application might be open to all kinds of funky security holes. And yeah, it increases the testing burden because you now have to test essentially all permutations that your object can have to make sure it works, and that's a lot of permutations. There's also a second, more famous guy than me, Mario Fusco, who's, it's better in writing because you don't have the accent. At one of the Devox, I think 3 years ago, they made a poll of the Java architects and about their biggest mistakes. And yeah, serialization is top one. It's their probably most regretted feature after null. So, and well, I like to talk smart, but as I said, I make a lot of mistakes. And whenever I use this, because it's the default, it bit me. So just for me, it bit me when I was working with Akka Remote. It bit me when I was working with Akka Cluster. It bit me again when it was using Spark, because it's also the default. And finally, at my current project, we serialized our user sessions with Java serialization. I didn't pay attention, and of course, it bit me again. So it keeps happening to me, and please don't make my mistakes. Some small notes about performance. If you just roughly skim over the performance numbers, you can read it up there. It's mostly doesn't matter because all of them are pretty fast, and this guy at the bottom is pretty terrible. So basically, as long as it's one of a nice protocols, it's fast enough. If it's serialization, it's too slow. And if you're really about the last nanosecond, then this talk is not good enough for you. You need a deeper talk. Or you have to do the research yourself. So now, obviously, people might want to say, what are we going to do with JSON or XML? Because people like it. I had one colleague back then who really liked to read XML as it went over the wire. Don't know why, but people are people. They have different interests in life, right? He liked to read XML. Other people like to read JSON. It's widespread. You have good tooling coverage, and it's easy to debug, if you will. You can read what went over the wire and know what's wrong. But it's still, depending on which benchmark you ask, a pretty slow thing. It's pretty verbose, so if you want to save bytes over the wire, it's not the right thing to do. But more important, number handling in JSON is really terrible because it's derived from JavaScript that doesn't know about numbers and precision. And in XML as well as in JSON, character encoding is a tricky thing. So as soon as you're not super sure that your application is only running in the United States with ASCII characters to 127, you might face some interesting problems down the line. And what's also bothering me is you can have schemas about JSON and XML that describe how your data is is able to look like to other systems, so you kind of can describe how it should be looking, right? We all know XLT. But they have no sense of evolvability. So think back what I said before, systems should be able to change. Once you have an XLT schema, that's it. If you have, as soon as you have a Beeson schema, that's it. It's gonna stick. So it's really hard to change things later on. And this talk is mostly about changing the mistakes you made. So just imagine it again. Imagine you have a pretty run-of-the-mill Hello World application. You need a Kubernetes for that, otherwise it doesn't work. And you have different instances of your application, a version 2 and a version 1, and you deploy different, like you start deploying it and you exchange some container with the version 2 and the rest is still version 1. And in your message queue, you have all kinds of messages from old versions of your system, right? The 2.0, the newest thing, wrote something, the 1.0 also wrote something, and there's still a 0.9 lurking somewhat, some old message. And it would be very cool if all of these people, whoever receives that messages, would be able to deal with it and not crash. That's a preferred outcome. So that means two things. One is backwards compatibility. That means this guy, the app version 2, it should be able to read old stuff. That's nice. You should be able to read what happened before you. You can always implement that the hard way, right? You can make ifs and ifs and ifs and ifs. If this is there, you view how it was before, so you can kind of fix it in software if you want to. Read the message and then see what's in there and make some sense out of it. But what about the app version 1 reading a message from version 2? There's something new in it that you didn't know before. So that's painful, because how do you deal with things you don't know about? How do you deal with, there's new data in there, there's some data went out, right? When we wrote applications in the 90s, we would ask people for their gender. We don't do that anymore because it's kind of pointless. But we might instead ask them what's their preferred way of being addressed, what's their pronouns. You could ask that question. So there might be new stuff in, there might be old stuff. And whatever you think about your entities, it's going to change. So no concept lives for very long, not even an account in a bank, or the concept of an account in a bank should be pretty fixed by now. They're doing that for 400 years, but everybody who knows in a bank knows, or works in a bank knows that everything is constantly evolving. So you need to be able to evolve with your concept of business. And the cool thing is there is software for that. We don't have to build it ourselves. There are different protocols that we can use, and I'm going to show you 4 of them today: Protobuf, Thrift, Avro, and Cryo. It's the one that I used to evaluate in the years before, and I kind of have some opinions on that. Doesn't mean that it's exhaustive. There's plenty more out there, but you could call them some major players. They have some relevancy, and you can cause a lot or cover a lot of cases with them. So, starting with Protobuf, our most obvious friend. It's from Google. They call it their language-neutral, platform-neutral, extensible mechanism. Think XML, smaller, faster, and simpler. So it's not just a schema, it's a whole small ecosystem. And now you could ask, why do I want to use something from Google? They abandon everything they start. And you're right, they abandon everything. But the good thing is they used Protobuf as a core for the Google Cloud Platform. Everything within the implementation of Google Cloud Platform uses Protobuf, so they're stuck with it. They have to keep maintaining it. That's our benefit. Only use Google stuff if they can't get rid of it. And what Google provides is not just the specification of the protocol, but also a lot of tooling around it. For example, the ProtoC, the compiler itself that compiles data with a schema or can serialize and deserialize stuff, and also some compiler plugins for Java. So if you write your schema, you can get some very nice Java classes for yourself. And for Scala. If you deal with Scala, there's also a ProtoC plugin for Scala that just calls the same compiler, and it will generate your Scala case classes, parsers, serializers, everything you need. So from Google, you get a one-stop tooling to really use it. Now, the question is, how would something like that look in reality? The definition of such a message has kind of this syntax. You define what a message is, you have your data types, and very important you now see is every data type has its unique number. That is then burned because it's a leaky abstraction because the ordering of data is important to Protobuf. That's why you have to give numbers to your things. You can have additional annotations, for example, the package thingy. That's not used for serializing messages, but it's very helpful if you generate classes because they will be then in the right package already. And then the funky thing comes, there's Proto 3, and for everybody who overslept the war, there were some significant changes between Proto 2 and Proto 3 that we unfortunately have to cover. So just if we have a quick look at how that stuff looks in Scala, we see that there is that's the same thing I just showed you. And if you want to use it, and I I hooked up the ProtoC compiler, you can see the source code then on my GitHub. You get a very nice case class person. That thing, I didn't write it. It got auto-generated for me. I get a nice builder pattern. And I can deal with that thing like any other stream, like I would do with Scala anyway. So I can write it to an output stream or write it to a file. I can read it again from the file, and hopefully it should still be the same thing. And one thing you can also do is, in this case, I added a field called what's my favorite conference, obviously the Vox days. And in this test, I read something from an old version, like I first serialized some data out, then I changed the whole definition, and now I read it again, and the whole thing should still work. And as you see, the tests pass, it still works. So it's a pretty seamless and nice integration. Wait. So now let's look at that, how that really works, how stuff looks on disk, because it's actually not that scary, and you can just take a look at it. If you open such a file that gets generated with a hex editor, which I have prepared for you. And unfortunately, the description how it looks in binary is this small. I can't make it any bigger. I haven't found a better tool. Sorry about that. If you open that file in a hex editor, you see that my previous object that I wrote, I left out the ID, and it just contains my name for simplicity. It's super easy. In the beginning, there is 5 bytes that tell you the ID of the field, and 3 bits that tell you the data type. Makes it 8 bytes, 1 bit, and within the first bit, you know which ID or the ID of the field you're reading and the data type you're reading. Then they spend another byte on the length, which says, okay, now there come 9 characters, and there come exactly 9 characters, which make up my name, and that's it. And because of the length field, you know how to stop to read, when to stop to read. And then the history repeats. We have the next byte that tells you, oh, look, now it's field number 3 with the same data type of string. It's exactly 3 bytes coming, and 3 bytes are coming, and the whole thing is over. That's all there is. So it's a very minimal way of putting data together, but it's also a pretty sane way, right? I could change 1 character of that. It doesn't let me do it, but I could delete 1, and then it doesn't fit because of the numbers again. Because right, I said it's gonna be 9. I can't give you 8. It's gonna break. But otherwise, you can replace a character. It will still work. So you don't have to memorize the detail. What I want to tell you about it, there's no big magic about it. It's a pretty obvious thing how you would slim down and serialize your stuff. For once, they didn't go overboard. And Now, what happened in Protobuf 3 versus 2? Because if you look around the examples on Google, there's all stuff written in 3. So what happened? In the beginning, they had a presence logic where you said, these fields are required. And it turned out, again, that this was a not very wise decision. In the beginning, it sounded obvious. You have your entities and a few things you really want to make sure they are there. For example, the name of a person. You could reasonably assume a person should have a name. Until you leave your little bubble of European sanity and go to other countries and find out that Brazilians have a ton of names, and it's a very complicated thing how Brazilians are called. And you find out that names are not as easy as you thought they would be. Or what nobody in Germany knows is how Russian last names are declinated based on the gender of a person. It's very unknown to European or German people. So there's all kinds of misunderstandings. And as you go along and as you have users from all over the world, you have to fix that. So what Google then did was said, as an internal guideline, everything is optional. Because once you have something required, you're stuck with it. It has to be there forever. And even if it's wrong. So they had their internal little war, and there's a long, long list going on in their internal mailing about when they discussed it. And they decided to completely remove the required idea. And since they were already at it and they owned the protocol, they just removed the whole thing and said, everything is optional. Which sounds counterintuitive, but if you get used to it, it's a very nice thought, because for full systems evolvability, everything is optional. You can't believe anything or you can't trust anything to be there. And they added some small new features like map types, time values, that are nice but not that breaking. So, that about it, yeah. And why did they ban it? Well, they had loads and loads and loads of production issues because this whole required thing didn't turn out as well as they thought. And as you know about Google, they have a lot of systems, so stuff breaks easier than with our little tiny projects. So, now some other sample that I prepared. How would that look in Java? Because I also hooked up the ProtoC compiler. And here's your standard run-of-the-mill Spring Boot application that has a controller and then mapper, services, all that behind. Ignore that for now. Where you can interact with Protobuf here. So, and here's the interesting part. I get some raw bytes from the outside, from the dangerous outside, and I can nicely parse them, and I get a very nice tracking event out of this. Don't worry about the details of the tracking event right now. And then I can take the data and push it into my service and have something. And if I want to create such a thing, I also get a nice little builder where I can set things and return them again to the outside world. So if I want to communicate to the outside world over Protobuf, it's a very easy and nice thing to say it. It's very well integrated in the Java ecosystem. So if I want to, for example, use this, if I post one of these events, for example, this is a serialized Protobuf thingy that I have here. I prepared it. It's the same principle as I just showed you. If I throw this against my web server and he takes it in, and then I call my whole thing, I get some, I can use it, right? This is more proof that this is not just sample code, it's working code. You can download it later on my GitHub if you want to dig into it. The details don't matter much. What I say is that little thing of configuration, you need to make it work. They have prepared very good tooling for it. And, well, that covers Protobuf. And then we have a second friend that we want to cover who's called Thrift. And that's even bigger. It's a whole framework, what Thrift means. It's a serialization protocol, but it's also way more, and even more exhaustive than Protobuf wants to be. It comes from Facebook, but again, Facebook acts like Google. When they invent something, they feel clever about it. As soon as people use it, they abandon it because they want to be the only ones who use it. And so it got open sourced, and it got taken over by a consortium, if you will, and somewhere later they re-open sourced it as Facebook Thrift, and nobody cared about that thing. So I'm talking about the original, the OG of Thrift. And conceptually, it is pretty similar to what Protobuf does. So there is, yeah, it went into the Apache ecosystem, and there's a lot of tooling around it. I would say it's a bit more complicated to use than the Protobuf tooling. But concept-wise, it's largely the same. So if we want to go over, sorry, if we want to look at a test how you could deal with something in Thrift and that in Scala, it's a bit more noisy because it's a whole family of protocols, so you need a factory and work with memory buffers. It leaks a bit more the details of what it's trying to do, which might make sense in your case or not. It's up to you to decide. But basically, you still get a class generator that generates you something, right? Here with a constructor instead of a builder, but otherwise largely similar. And then if you talk Scala, I'm going to go quick with it, or just a quick poll. Who's using Scala in their daily life? 2, 3, 4? Okay, so let's cover it quickly because it's not the majority. Twitter supplies Scrooge. Right? We just heard today in a talk that Twitter is still somewhat invested in Scala, and with Finagle, so they still supply things. We can trust them to be around for 1 more year. If you want to look at the schema, it does look oddly similar to Protobuf. You've seen before. Okay, it uses a different keyword, but the same syntax. The only thing that's really different is they still have the semantics of optional and required. If you want to compare them, that's where they are the most, or the most different. Otherwise, a lot of the concepts are shared. So we've seen that. But if you look at the stuff on disk that happens, they have still the same things happen, right? So you get a type information, you get an ID information, which field you're talking about, you get a length information, and then you get the full bytes. I'll show you the file on disk a bit later. The only thing that really differs a bit is that they have been way more generous with how wide a thing can be, right? They have 4 digits to use your field IDs, so they probably estimated lots of fields and messages. And for the length, it's 2, 4, 6, it's 8 digits. So you could make a very long length. They probably anticipated way larger messages than Protobuf does with their 1 byte each policy. So that might be a hint of what they were trying to do back then. Just for complacency's sake, this is a Thrift file, and if you compare it to what we had before, it's largely the same, right? We still have the bytes for my name, we still have the bytes for my last name, we still have the numbers of a length of 3, a length of 9. It's just padded with a lot of additional zeros. But basically, it's the same. You have a type, you have a length, you have an ID, you have a length, and then just come bytes, and you can read that. So conceptually, it's a very similar thing. Now, what comes with it, and you need, as always, you don't marry a person, you marry the whole family. You get a whole RPC framework with it. And they call, it has a different family of encodings. Some are more used for learning, for reading, or for human consumptions. Some are more optimized for being on the wire or for storage. Yeah, the Scala ecosystem gets contributions by Twitter. The rest gets contributions by the whole Apache family. But there's a big similarity. Now, the third contender that we have on our little list, Avro. And Avro is way different than the 2 we had before. So it started as a sub-project of Hadoop, something we all heard and forgot about it already. Because Thrift, even if it suggested big messages, it was a bad fit. Because Thrift, as Protobuf, they all like to have a lot of definition before things happen. You usually make your mind up what your entities look like when you start, and then you modify them. And Hadoop works on random things and tries to make sense out of it. So it was not the perfect fit for them. And it started as an Apache project, but was later picked up by Confluent, the company behind Kafka. So they picked it up, they're the largest influencer, and they really integrated the whole thing. Avro has become a part of Kafka by now. That's a bit polemic to say, but these things are really intertangled. And it has two schema languages. One is for humans to read, and one is for machines to consume. And it can directly interact with and from JSON, which could occasionally be very nice. Now, what you need to remember if you think about how Hadoop was, Hadoop was not intended to work with a high frequency of very small messages. It's intended to work on very big files, on petabytes of data somewhere in the data center, doing MapReduce on them and then all the crazy magic. So it is a different use case, and it reflects on what this protocol has become. It's intended for big, large messages. And it also thinks way more about decoupling. So for Protobuf, if two things want to interact with each other, they share the schema. They both need to know one version of the schema that works. And for Protobuf, they can be wildly different, the reader and the writer schema. Because sometimes the reader schema just gets discovered as you go. Because somebody wrote it, and then that somebody is long gone, and somebody else has to come and read it, and they can't really exchange information anymore. So in the payload, there's less type information, so the payload gets small, but the schema around it gets big. And there's no manual assigned field IDs because everything is pretty random. Right? And that boils down to having different schemas for reading and writing. This has an, we'll come later to it. It has an interesting effect in that you have to keep your schema around somewhere. For Protobuf, if somebody knows about the schema, and he can then attach it to the message itself. You don't have to couple the message with the schema in Protobuf and in Thrift, but in Avro, they have to stick together somewhat. Now, if you want to interact with it software side, it's also pretty similar, right? You have data types, you have some namespace annotation, some protocol definition. What you see here is there is no numerical ID. Fields can come and go as they like, and you can flip things around. In a Protobuf message, the ID has to come before the first name, or it needs to be marked as what it is. Avro just reads one thing after another and then tries to make sense out of it, according to the schema. Sorry. So Java usage, you get the serializer, if you see. Here you see the influence of Confluent popping up. They do most of it. In Scala, you would use Avro Hugger and Avro 4S, which is a very community-driven approach. So for Scala, there's no big company behind it, if you will. We got to really go quick this time. Let's skip this because it looks oddly familiar. And the very important thing is the encoding on disk. It probably gets more impressive. Remember how Protobuf looked. Remember how Thrift looked. And this guy is Avro. Makes sense, right? No, what they do here is, you kind of see it in the beginning is the whole schema on what this data does look like, and then in the end comes the data. Now that makes sense if you have a gigabyte big message, you don't care about these few bits in the beginning that describe your data. If you just transmit that little thing, it's gonna get annoying to keep your whole schema around. It's a lot of overhead. But it needs to be there, and there are, I mean, that's the easiest way to just snip it in or just pack it in the message. But what Avro and Confluent also did was to invent some kind of schema registry. Let's, so you could just stick it in a message, or you can take it out again, the schema, and give it some ID and retrieve it later and find out, okay, if this is my schema ID 15, I need to fetch that schema and then make sense out of my data. Or you buy a schema registry from Confluent, which works very well with Kafka together, and do it in the whole family style, or work with the product offerings. So if you want to do that, you get, it's very dynamically. So Protobuf Thrift wants to be handcrafted. It's simpler with dynamic languages, right? If you do a lot of JavaScript, the dynamic part of it helps you. And the downtime is you have some problem with keeping that schema around, right? You either have the protocol overhead, sending the whole thing, or you need a runtime dependency to the registry, which I very much don't like. But it seems to be working well in the Kafka ecosystem. Now, guy number 4, the odd one of our list, Cryo. Cryo is, I put it on because it's getting very interesting in Akka or in Vertex, in a lot of fast JVM to JVM communication. It gets used and it gets a lot of traction. It's odd because it doesn't support schema evolution, but it's super fast. So for live cluster communication, it's a good thing. What I did before is trying to serialize things for long-term storage, and it was terrible. I would never do it again. But if it needs to be really quick, you might want to use it. So here's some small Java sample, how it would look like. Since it has really no schema, you just put things in it, and deserializing it, you hope you have a similar definition on the other end. But compared to Java serialization, it's a safer and sane way to do an insane thing. So if you want to do it with SPT, you would use chill. Let's skip that part. And now it gets really interesting. How does it look on disk? Because it leaves out a bit of field ordering information. We can compress the message we had before. If you look back here, it was, I think, 32 or something. No. It's a bit here, and here's then Cryo, because it gets stuffed everything super together. It doesn't even stop at the byte limit. If you don't need all 8 bits, it just stops and starts with the next thing. So you can stuff the whole thing in the most condensed way possible. That's, if you still want to keep type information around, this is the smallest thing you can make my name to be. So if you care about transport overhead, Cryo is a very interesting thing to do. So again, summary is it doesn't have a schema, it doesn't have any evolution, but it's super quick and it's super easy on the wire. If you need that, Cryo is an interesting thing to take a look at. And because I lied to you, it's not 4, I'm talking about 5. There's also simple binary encoding. It's super optimized from the, let's see if it's from Aaron. Sorry, I had that name on my tongue. Sorry for all Aaron people in the audience. Company behind it is Real Logic. They have that Aaron messaging system, which is its own messaging product that you can use for inter-JVM communication. It supports schema evolution, and compared to the 4 we've seen before, it's definitely faster, but it's also definitely more complicated. So, and because of the ease of use and the integration, it's not so simple, but if you need to really optimize for the latest nanosecond, take a look at these guys. So, summing it up, that's the slide you take a picture of, but I also have all slides published. Protobuf is great for integration. I really like the concepts. The version change from 2 to 3 was a bit of a hassle, and it's confusing to everybody around. For Thrift, it shares the concepts. It's a bit of a bigger framework that might be useful or disuseful for you. Depends on your use case. The integrations are not as good as in Protobuf. For Avro, the integrations are great. It's a great thing for big files, and I have a conflicted idea about that whole embedded schema concept, right? It's a narrow case where it makes sense. Cryo has terrific speed, terrific simplicity, but it sacrifices schema evolvability, and it's not good for persisting. It's really for live communication. So depending on what you are building, I can't tell you what's better. I can tell you 4 things, how they are different. And then it's up to you as a software professional to find the right tool for your job. And yeah, one last thing, what the Google people learned, required and schema evolution, they don't mix very well. They had their problems, so be very cautious about that thing. And of course, no Java serialization at all. If you want to read more, of course, effective Java is always a recommended thing, I guess in every talk. Designing data-intensive applications was released last year from Martin Kleppmann. It's a fantastic book. Everything of my talk is a tiny chapter, and the rest is pure awesomeness. It's a fantastic book, and I cannot recommend it more. And the short digestible version is here. That's this blog post that also explains some of it's also from Martin Kleppmann, that explains some of the concepts I had in this talk. So yeah, if you go to my GitHub, you also find the links there. All right, that concludes it. My Twitter is Chris. Go there if you want to complain. On GitHub, there's all the examples. I might later tweet about it. And as a short teaser for tomorrow, because I still work for Mathmatch, we release 5 times a day with a team of 5. If it gets crazy, we release 15 times. If you want to know how we pull that off and why we do that nonsense, see me tomorrow. Thank you very much. Any questions? I'm happy to answer them. Do we have a microphone to pass around? Okay. Now we just need questions.
Want to argue a little bit about the disadvantage of embedding schema to Avro.
Excuse me, it's hard to understand.
Want to argue a little bit about disadvantage of embedding schema to Avro. The matter is that when Avro is used for persistent storage, the embedded schema is probably an advantage, not disadvantage. Because in this case, yeah, I can transfer between layers, for example, a lot of data without knowing what it is, and then interpret it properly at the point when I need it.
Right. It's a good point, right? If you want to store data for a really long time, like I said before, if the writer and the reader don't have to know each other and there's a large time difference, it might make sense